Okay, guys, part C. At time t equals 2, train A's position is 300 meters east of the Oregon station. So guys, that's an important little thing here. They're telling you the position at time 2 is 300. Okay, so the position at time 2 is 300 east of the Oregon station. Okay, east to the right. And the train is moving to the east. Okay. Write an expression involving an integral that gives the position of train A in meters from the origin at time t equals 12. So guys, that would be, I'm looking for the position at time 12. Position at time 12. It's going to be the position at time 2 plus the integral from 2 to 12 of the velocity. Okay, so that's an equation involving an integral. If you want to be careful, you know the position at time 2 is 300, so it's 300 plus that, VA T dt. Okay, so I got part 1 done. That is worth a point. Now what do they ask? Use a trapezoidal sum. Use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time t equals 12. So guys, what they want you to do is they want you to use the table and a trapezoidal sum to do this. Now watch out. The table starts at 0, but they only want the integral from 2 to 12. So there's 3 intervals. That's 1, that's 2, that's 3. So when you do the trapezoidal sum, you're going to get SA of 12 equals 300 plus, okay, here we go. Remember, trapezoidal sum, it's the average of the y's times the difference of the x's. So the first one's going to be 100 plus 40 over 2. I'll tell you guys, to save a little time, I'll bag out, I'll write these down, and I'll come back and show them to you. Let's see, guys, to save a little time. So look, this is the first 2 y values added together divided by 2. The x value is 5 minus 2. Okay. The second 2 y values added together divided by 2 multiplied by the difference of the x values. The last 2 y values added together. They're both negative. Divided by 2 and then multiplied by the difference between the 2. So let me do that math. Okay, guys, so that goes down to this. 70 times 3 minus 40 times 3 minus 135 times 4 is negative 450. So this is 300 minus 450. So what I end up getting is S of A of 12 equals 300 minus 450 equals negative 150. That's the answer. Okay, so that's part C. Sorry, I should have said negative 150 meters. And that's west of the station. Okay, so I'm not sure approximate position. So negative 150 meters. I guess you could say negative 150 meters east of the station, or you could say 150 meters west of the station. Okay, so let's see, what are they looking for in part D? Okay, a second train B travels north from the Oregon station at time t. The velocity of train B is given by this, so they're giving me the velocity of this other train. At time t2, which is the same initial condition they gave me up here for the other one, north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2. That is rate that something is changing. Find the rate at which the distance is changing. Guys, you should think related rates. Okay? So what you've got here, let's draw the problem. Okay. I've got SA and I've got SB. Okay? So this is the distance between them. Trains A and B. Okay, to make my life easy, I'm going to call this X. I'm going to call this Y. I'm going to call this z. So I've got z squared equals x squared plus y squared. Okay, it's a related rate. I'm going to have to take the derivative of everybody with respect to time. It's 2z dz dt. So I take the derivative of the first term, but I also have to take the derivative of z with respect to time. Equals 2x dx dt plus 2y dy dt. Okay, everybody's got a 2, so I can accept that. So what do I know? I know that x equals, okay guys, they told me x is 300 meters east of the station. At time 2, the train is 300 meters east. Okay, so at time 2, the train is 300 meters. So I know x equals 300. In this problem, they told me y equals 400. They're very nice. It's a 3, 4, 5 triangle. So z equals 500. Okay, so I know this, I know this, I know that. What else what am I trying to find? I'm trying to find the rate that the distance between them changes. So I'm trying to find dz over dt. Okay, so I better have dx over dt. Do I have dx over dt? Does that show up anywhere? Let's see. At time 2, that's dx over dt. So dx over dt equals 100. Okay, dy over dt. Well, guys, they gave me an equation for the velocity. I'm going to have to plug 2 into that equation. So it's negative 5 times 2 squared plus 60 times 2 plus 25. That's 4. That's negative 20 plus 120. That's 100. And then plus 25 equals 125. So I know dx dt, dy dt, I know x, I know y, I know z. I'm going to plug everybody in. So I get 500 times dz over dt equals 300, which is x, times 100, which is dx dt, plus 400, which is y, times dy over dt, which is 125. So let's see. So I've got 500 dz dt equals, let's see, this is 3, 1, 2, 3, 4 zeros plus 400 times 125. Let's see, 4 times 125 is 55. It's going to be 5, 1, 2, 3, 4 zeros. So I get dz over dt equals 80,000 over 500 meters per minute. You can leave it like that, guys, if you want. I see in their solution they get 160 meters per minute, which would be fine as well, but you can leave it like this. So there's a related rates problem. So this is a nice problem. Started with the simple algebra 1, delta v over delta t. Intermediate value theorem, I did screw up in the beginning. I should have read more carefully that it was looking for a velocity, and that's what I had, velocity. If it was looking for an acceleration, that would have been mean value theorem. It was looking for a velocity between these two times, so it was intermediate value theorem. So did that. Then a nice little trapezoid problem, and it ended with related rates.